All right, kids. So what we're doing here is the pH spreadsheet that I wanted you to do, and it doesn't take that long, but I just wanted to use it um, to show you what we know about water. And water, as you see here, we have the H pluses are these red, and the OH minuses are the blue. And if you multiply the concentration of both of those, they always equal 10 to the minus 14. So as one goes up, the other one goes down. So here's a very basic solution. And here's a very acidic solution. And the reason that happens is because the two of them have to equal 1 times 10 to the minus 14. So let's prove that here. So what I've done is put some concentrations here of some different acids and bases. And plus, as I told you, I love for you to know how to do this, because while many of you will not do chemistry, many of you will definitely do a spreadsheet. So we want to know the product of these two things to prove that that equilibrium constant, that water always has 10 to the minus 14. So what we're going to do is we're going to put equals to let the thing know we're doing math. And let's see who's in there. Wesleyan is right now talking right there with me. All right, so it equals this number, and then the times is going to be the shift 8, so that asterisk or star above the 8. And then you want to multiply that by the concentration of H plus, and when you multiply those, you get 10 to the minus 14. And remember, if we want to do that for all of these, spreadsheets are smart. They'll figure out that you want to do it for every row. But what you have to do is highlight this box and then put a little cross on it and then drag that down. And now it's going to repeat that equation all the way down. So as you see here, this is now C4 times B4, and this will be C5 times B5. So it's multiplying these numbers all the way down. And in each case, we get 10 to the minus 14, which is what we learn in chemistry, that all the time the concentration of H plus times the concentration of OH minus equals 10 to the minus 14. That's an equilibrium constant. All right, so then the next thing we want to know is the pH. So pH, you may remember, is equal to, so we say equals, and it's the negative log. And as you write log there, you'll see log 10 show up here. So let's click on that. And we want the negative log of the concentration of H plus. So we want that of this thing. So we're going to click that box. And so it's making equals the negative log base 10 of B3. And then you hit enter, and that'll tell you that this is basically 10 to the power of negative 1. And since negative 1 becomes positive, since we said negative log, that's why it's a positive 1. And then we drag this down, and you can see that it goes 1 all the way up to 13. And what this is telling you is that basically the exponent to this number. So 10 to the minus 1 has an exponent of 1 when made positive. 10 to the minus 2 has an exponent of 2 when made positive. 10 to the minus 3 has. All right. So this number, the point here, though, is that as the pH gets bigger, the number here is getting to be a much, much smaller fractional number. Right? 10 to the minus 13 is a very little number. So a pH of 13 means you have very little H plus. Very little H plus means it's a solution like this, where you just have the occasional red dot in there, but basically it's overwhelmed by blue dots. All right, so we're going to do the same thing with POH. That's equal to the negative, so the minus sign, LOG, and LOG base 10 will show up. And we'll click on that. And now we want, since this is the POH, we want that to be this number. Hit enter, and as you see here, it just says these all equal 10 to the minus 14. If you have a pH and a POH, they will always add up to equal 14. And if you don't believe me, just drag that down and you'll see 2 plus 12, 3 plus 11, 4 plus 10, on and on. And the same thing here, the same relationship is true with POH as pH. When the POH is a big number, that means the concentration is a very small number. Just like when the pH is a small number, that means the concentration is, you might not think a very big number, but compared to these other numbers, that's as big as it gets. And a large pH means it's a very small concentration. So this is more evidence and hopefully some exploration of the fact that as one goes up, the other one goes down. And so when your pH is going to be like 1, because this has a power of 10 to the minus 1, right, or 0.4 in this case, that means there's a whole lot of red stuff and very few blue things. And when the blue thing has a small number, therefore the red one has to have a large number. That means there are very few red things and a whole lot of blue things. All right, so that's what you got to do. Then turn that in on Classroom and you're good to go.